Okay, sorry. I stopped that video by accident. So what we're going to do is we're just going to do the first four examples together, and then you're going to try some on your own. So here we go. So example number one, what it's telling us, it's saying find the first four terms of the recursive sequence defined as below. So this is where you guys are going to really have to like delve deep into to understand what this recursive sequence is telling us. First, I'm going to write down little four spaces because it told us to find the first four sequences. Next, we talked about how this piece right here is our first number in the sequence. So I'm going to put -3 down here. Next, we're going to look at the actual rule of the sequence. It's telling us to take the previous number, that's what that means, subtract 2 to get to the next number in the sequence. This is our next term. This is our previous term. The right-hand side is what we're applying to get to the left-hand side, which is the answer to the rule. So what I like to do is I just like to rewrite it. I'm going to put -3, and we're going, because that's our first term, and we're going to apply the rule. The rule is subtract 2 to get to the next term. Plug that in your calculator, -3 minus 2, you get -5. So that's the next term in our sequence. We're going to repeat that pattern. So I take the next term, -5. I'm going to apply the rule where I subtract 2 again, and I get -7. So that's the next term of the sequence. And I'm going to apply that rule again. I'm going to take -7 minus 2, and I'm going to get -9. That's the last rule of our sequence because they wanted the first four terms of the recursive sequence. So all we're doing is we're using this rule that they give us in this crazy notation to find the other numbers in the sequence. So that's the first one. Pause the video and make sure you get all this down before we go on to the next couple. Now we're going to go on to the next example. The next example says find the fourth term of the recursive sequence defined below. So again, I'm going to write down my four little spaces, and just remember, you could rewrite it with words replacing a sub n minus 1, n plus 1, sorry, is the next term, and a sub n is the previous term. So if you're not sure, just remember, this is our previous term, this is our next term. So the first thing we do is we take our first term and we write it in our sequence here, which is 20. And the rule is telling us to take the previous term and subtract 4 to get to the next term in the sequence. So I'm going to take my first term, which is 20. I'm going to subtract 4 like it told me to do, and I'm going to get 16. So that's the next term in my sequence. And I'm going to follow this pattern. I'm going to take this 16, which is now my next term in the sequence. I'm going to subtract 4, and that's going to give me 12. So that's the next term. And now this becomes my previous term where I take 12 and I subtract 4, and I get 8. And 8 is the fourth term in our sequence. So this would be the answer to this particular question, would be 8. Not all four terms, just the fourth term. So copy this down to get the notes, and then we're going to move on to the next together. Okay, number 3. This one's a little different. The notation's a little different, but again, it all means the same thing. This says if f of n equals 2, which is our first term, and f of n equals -2 times f of n minus 1 plus 1, find the first 5 terms of the sequence. So we're going to write down our little 5 dashes to find the first 5. And now in this particular one, f of n minus 1 is our previous term. F of n is our next term. So this notation just means previous term to get to our next term. That's all it means. It doesn't mean any sort of application. It just means, or function notation, it's just another language to explain how to get to one term to the next term in our sequence. So again, we're going to fill out our first term as 2. But in this particular one, we're going to need to do a couple of operations. We're going to need to multiply by -2 and then add 1 to it. So I'm going to take -2 add 1, but I need to make sure I plug in my previous term. The previous term was 2 right here. So I'm going to take -2, times it by 2, add 1 in your calculator, and you should get -3. So that becomes my next term in the sequence. And now I'm going to follow this pattern. I'm going to take -2, times it by my previous term, and add 1. But in this case, the next term is -3. I'm going to plug that in. Plug in your calculator. -2 times -3 plus 1 is 7. So 7 becomes my next term in the sequence. I'm going to just keep following this pattern. Take -2, plug in the previous term, add 1. The previous term in this case was 7. So -2 times 7 plus 1 should give you -13. And again, I'm looking for the first 5 terms. So I'm just going to keep repeating this pattern. -2 times -13 plus 1 is +27. So that should be our first 5 terms of the sequence. So we're just taking that answer, plugging it in, and repeating the pattern. We're going to do one more together, and then I'm going to have you guys do a couple on your own. There is one challenging problem, which I think maybe only like 2 or 3 of you can get. But if you want to try it, text it to me, and I will let you know if you got it right. So here we go. Pause the video if you didn't get this, or rewind it to get to the next problem. Okay. So the next one, number 4, states. Again, weird notation. If f of 1 equals 2 and f of n equals 3 times f of n minus 1 plus minus 1, find the first 4 terms of the sequence. So as we know, we're going to write the first 4 down. I'm going to give my dashes out. This guy is my first term. And what this rule is telling me is to just take this out. This is our previous term to get to our next term. Now, this notation looks a little crazy, but this is why it's a recursive sequence. It's just, like I said, trying to interpret a foreign language. So our next term is f of n, if you want to fill that in, and then our previous term is f of n minus 1. All right, so now that we have 2 as our first term, we're going to take 3, we're going to multiply it by the previous term and subtract 1 to get to the next term. And what did we say the previous term was? It was 2 in this case. So we're going to take 2, multiply it by 3, subtract 1, and we get 5. Okay? So now we're going to take 3, we're going to multiply it by 5, subtract 1 to get to the next term in the sequence, which is 14. Oops, I forgot the 5 here and the 14. Goodness gracious, it's going quicker. Now I'm going to take 3, multiply it by 14 because that's the next term in the sequence. Minus 1 is going to give us 41. So we have all 4 terms of the sequence below. So really, it's just a matter of following the pattern. And if you could just find the numbers in the problem, kind of ignore that f of n and f of n minus 1 notation and just realize that's where you're plugging in the numbers to get to the next term, it could be a lot easier. Okay? Like I said, you could text me if you have any problems, or email me or send me a message, whatever floats your boat. But good luck, and hopefully you get this because this is, a big deal in Algebra 2, and the last thing we're going to be doing with sequences this year. Okay? Talk to you guys soon.